again, Jessica. Welcome back to GED on Mathematical Reasoning. I'll be leading you through Chapter 3. If for any reason you feel like you need to pause the video, please feel free to do so. You can always return back to where you last left off in the video. This program was designed to follow along with the book. Therefore, if you're ready to begin Chapter 3, let's go. Hope I can keep your attention. As a reminder, we'll be using the Kaplan GED Test Prep Plus 2020 book for Chapter 3 and all chapters covered within the GED On platform. You can find links below to purchase the book at your local stores or online. Also, please remember that your book contains access to the Kaplan Online Center, which contains access to additional instruction and practice materials that will assist you in being successful on the big test day. We'll be starting our third video by covering Unit 2, Mathematical Reasoning, Chapter 3, Ratio, Proportion, and Percent. Chapter 3 will be covering lessons 1 through 6, starting on page 260 of the Kaplan book. So let's go ahead and begin. Let's begin with Lesson 1, Ratio and Proportion. Ratio. A ratio compares two numbers. You can write a ratio by using the word to, using a colon, or using a fraction form. For example, a softball pitcher strikes out 4 batters for every 1 batter that she walks. What is the ratio of strikeouts to walks? The answer to this would be 4 to 1, using the word to, 4:1, or 4/1 as a fraction form. Always write the numbers in the ratio in the same order in which they appear in the question. Ratios are similar to fractions. They have 2 terms, and they can be simplified by reducing to lowest terms. For example 2, it says, Frank manages a small drugstore. During a 2-hour period, he counts 25 cash sales and 15 credit card sales. What is the ratio of credit card to cash sales? First, to answer this example, we'd write the ratio as a fraction with the terms in the correct order, credit card to cash sales. So for credit card sales, we have the number 15 over cash sales, which is number 25, in fraction form. Second, we reduce to lowest terms the fraction. So as shown here, we have 15 over 25, and we reduce it to lowest terms by dividing both 15 and 25 by 5, would equal 3 over 5, but our ratio for this example of credit card to cash sales would be written as 3 to 5. There are some fraction rules that ratios do not follow. So remember, do not change a ratio that is in a proper fraction to a mixed number. Also, if a ratio in fraction form has a denominator of 1, do not write it as a whole number. Leave it in fraction form. Another important difference is in the use of labels. The terms in a fraction have the same unit labels, such as 5 over 6 in fraction form of a pie means 5 slices out of 6 slices. Ratios may have different labels, such as the sale advertised 6 cans for $1 or a 6:1 ratio. To write a ratio, you may need to perform one or more basic operations to find one of the terms. For example 3, it states, a football team won 12 games and lost 8. There were no tied games. What is the ratio of games won to games played? To solve and answer this example question, we would first see that the problem does not tell you the number of games played. Therefore, we would add the games won to the games lost to find the games played. So it would be 12 won plus 8 lost equals 20 played. Second, we'd write the ratio in the correct order and simplify. So we have in fraction form 12 out of 20, and we would divide it by 4, which would give us 3 over 5. And our answer would be the team won 3 games for every 5 games it played, a 3:5 or 3:5 ratio. Now that we've gone over ratios, let's view our very first practice, practice 1.1, found on page 261. For our first practice questions, we're going to write each ratio as a fraction in lowest terms. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll be reviewing them together afterwards. Click play when you're ready to continue. Welcome back. Let's now review the following 3 questions together. Question 1 says, Stan made 24 sales in 6 hours. What is the ratio of sales to hours? To solve this question, we need to first write the ratio as a fraction. So we'd write it as 24 for the numerator and 6 for the denominator. Afterwards, we'll reduce the fraction to lowest terms by dividing 6 from the numerator and the denominator. This will give us our answer of 4 over 1 in fraction form. For question 2, it says, Carol's monthly take-home pay is $1,500. She spends $250 a month on food. What is the ratio of food costs to take-home dollars? To solve question 2, we would do the same process as we did in question 1, with first writing the ratio as a fraction. So we would write it as $250 for the numerator and $1,500 for the denominator. Afterwards, we'll reduce the fraction to lowest terms by dividing $250 from the numerator and the denominator. This will give us our answer of 1/6 or 1 over 6 in fraction form. For question 3, it says, a toy rocket travels 180 feet in 15 seconds. What is the ratio of feet to seconds? We will repeat the same process as questions 1 and 2, with first writing the ratio as a fraction. So we'll write it as 180 for the numerator and 15 for the denominator. Afterwards, we'll reduce the fraction to lowest terms by dividing 15 from the numerator and the denominator. This will give us our answer of 12 over 1 in fraction form. You may now pause the video and complete practice 1.1, questions 4 through 14. Click play when you're ready to continue. Proportion. A proportion is an equation that shows that 2 ratios are equal. The cross products in a true proportion are equal. In other words, when you multiply diagonally across the equal sign, the products are equal. Example 4 says, directions on a can of powdered drink mix say to add 3 cups of water to every 2 scoops of drink mix. Matt adds 12 cups of water to 8 scoops of drink mix. Did he make the drink correctly? In order to solve and answer this example question, we would first write a proportion, making sure the terms of the ratios are in the same order. So we have in fraction form 3 over 2 equals 12 over 8. Second, we would cross multiply and compare the products, as shown here. When cross multiply, we have 3 times 8 equals 24, 2 times 12 equals 24. Since the products are the same, the ratios are equal. Therefore, Matt made the drink correctly. In most proportion problems, you are asked to solve for a missing term. Example 5 states, a map scale says that 2 inches equals 150 miles. What actual distance would a map distance of 5 inches represent? In order to solve and answer this example question, we'd first write proportion with both ratios in the same form, inches to miles. The variable x represents the unknown distance. So shown here in fraction form, we have 2 over 150, 2 being inches, 150 being miles, equals 5 over x, x representing the unknown distance. Second, we locate the term in the first ratio that's diagonal from the known term in the second ratio. We would cross multiply, which would give us 150 times 5, which equals 750. Third, we divide the result by the remaining known term to find the value x. So we would take the 750 divided by 2, which equals our answer of 375 miles. Some proportion problems ask you to find a rate. A rate compares a quantity to 1. When a rate is written in fraction form, its denominator is always 1. In word form, rates are often expressed using the word per. For example 6, it says, Connie drove 276 miles on 12 gallons of gasoline. How many miles per gallon did she get on the trip? In order to solve and answer this example question, we first need to find how many miles Connie drove on 1 gallon gasoline. So we write 276 over 12 in fraction form, 276 being the miles, 12 being the gallons, equal x over 1. Second, we would solve. We'll solve by 276 times 1 equals 276, and then taking 276 and dividing it by 12, which will give us our answer of 23 miles per gallon. Using your calculator, you can solve proportion problems in one series of calculations. Example 7 says, find the value of x in proportion 6 over 16 equals 21 over x. To solve and find the answer for this example question, you need to multiply 16 and 21, then divide by 6. On the TI-30XS multi-view calculator, you'd first press the number 16, then press the multiplication sign button, then press 21, then press the division button, then press the number 6 on your calculator. Second, you would then press enter. The right side of the display on your calculator will read 56. This will give you the answer of the missing term, which is 56. Note, when working a problem, ask yourself if it can be solved using proportion. This may be possible when two quantities are compared or when three values are given and you're asked to find a fourth. Now that we've gone over proportions, let's view our second practice, practice 1.2, found on page 263. For our next set of practice questions, we're going to solve for the missing term in each proportion problem. No, answers will not always be whole numbers. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Great, you're back. Let's now review the following 3 questions together. First question says 2 over 3 equals x over 18. To solve this question, we need to first cross multiply 2 times 18. 2 times 18 equals 36. Therefore, we'll divide our result, 36, by the remaining term, 3, to find the value of x. This will give us our answer of 12. Our second question says, 3 over 5 equals 27 over x. To solve question 2, we'll do the same process as we did in question 1, with first cross multiplying 5 times 27. 5 times 27 equals 135. Therefore, we will divide our result, 135, by the remaining term 3 to find the value of x. This will give us our answer of 45. Lastly, question 3 says 6 over 5 equals 3 over x. We will repeat the same process as questions 1 and 2, with first cross multiplying 5 times 3. 5 times 3 equals 15. Afterwards, we will divide a result, 15, by the remaining term, 6, to find the value of x. This will give us our answer of 2.5 or 2.5. You may now pause the video and complete practice 1.2 questions 4 through 22. Click play when you're ready to continue. We're now moving along to lesson 2, percents. Percent means per 100 or out of 100. For example, if you have $100 and you spend $25, you spend $25 out of $100, or 25% of your money. Since percent is a way of showing part of a whole, it has much in common with fractions and decimals. To convert a percent to a fraction, write the percent over 100 and reduce. To convert percents to decimals, drop the percent symbol and move the decimal point 2 places to the left. In any percent problem, there are 3 elements: the base, the part, and the rate. The base is the whole quantity or amount that the problem is about. The part, also called a percentage, is a portion of the base. The rate is a number followed by the percent symbol. For example 1, it says, at a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, part, and rate in the situation. The entire bill of $20 is the base. The $3 tip is part of the base, and the rate is 15%. One way to think of a percent problem is as a proportion. In example 1, there are 2 ratios. $3 tip is part of the $20 total bill, and 15% is the same as 15 over 100 in fraction form. Since the 2 ratios are equal, they can be written as a proportion, as shown here. You would then cross multiply to prove the ratios are equal. So it would be 20 times 15 equals 300, and 3 times 100 equals 300. You can solve percent problems by setting up a proportion and solving for the missing elements. Just remember to express the percent as a number over 100. For example 1, it says, at a plant that manufactures lighting fixtures, it is expected that about 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? In order to solve and answer this question, we would first write proportion. Remember that 2% means 2 out of 100. Use the variable x to stand for the number of defective fixtures. So we have here written x which is the variable to stand for the number of defective fixtures, over 900 equals 2 over 100. Second, we will solve for x. We'll cross multiply and divide by the remaining number. So it'll be 900 times 2 equals 1800. 1800 divided by 100 equals 18. Therefore, our answer for this example question is the company can expect about 18 defective fixtures. Now that we've finished learning about percents, let's go and proceed to practice 2, found on page 265. For our second practice questions, we're going to identify and label the base, part, and rate for each situation. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Glad you made it back. Let's now review the following 3 questions together. Question 1 says, Victor owes his uncle $1,000. Recently, he gave his uncle $200. The payment was 20% of the money he owes. For question 1, we need to first identify the base. That is the whole amount that the problem is about. Based on question 1, the base is $1,000, the amount Victor owes his uncle. Next, we'll be identifying the part, the portion of the base. The part for this question is $200, due to how it is the portion of the base, $1,000. Now let's find the rate. The rate is the number following the percent sign. The rate for this first question is 20%. Second question says, on a test with 80 problems, Sophie got 72 problems right. In other words, she answered 90% of the problems correctly. For question 2, we'll do the same process as we did in question 1. So let's first identify the base. Based on question 2, the base is 80, the total amount of problems on Sophie's test. Next, we shall identify the part. The part for this question is 72, due to how it is the portion of the base, 80. Now let's figure out the rate. The rate for this second question is 90%. Lastly, question 3 says, the Kang family made a down payment of $2,740 on a new car. The down payment was 20% of the purchase price of $13,700. For question 3, we will repeat the same process as questions 1 and 2. The base for this problem is $13,700, the purchase price of the new car. The part for this question is $2,740, the down payment made by the Kang family for the new car, and the rate for the third question is 20%. We now pause the video and complete practice 2 questions 4 through 13. Click play when you're ready to continue. Let's now continue on with lesson 3, using the percent formula. Solving for part. You can also solve percent problems using the formula base times rate equals part. The following diagram below shows you how to use the formula base times rate equals part. To use the diagram, cover the element you need to solve for B equals base, R equals rate, percent, and P equals part. Then perform the operation that connects the remaining elements. Let's now review our first example for lesson 3. Example 1 says, a company offers its employees 2 health plans. In a recent newsletter, the personnel department stated that 70% of the employees chose Plan A. If the company has 320 workers, how many chose Plan A? In order to solve and answer, Example question. We must use the formula base times rate equals part and identify the base and rate in this example question. Therefore, first, the rate for the example question is 70% and the base is 320, the total number of workers. We now must solve the part. Using the diagram, cover P for the part. You can see that you need to multiply to solve the problem. Second, change the percent to a decimal and multiply. So we're going to take the rate 17% and change it to a decimal, which is 0.7. Then we're going to take the base 320 and multiply by 0.7, which will give us our part, the answer for this question, 224. Therefore, out of 320 workers, 224 chose Plan A. Solving for rate. Rewrite the percent formula to solve the rate. Use the formula part divided by base equals rate. You can use the diagram to help you remember the formula. For example 2, it says, a computer system is regularly priced at $1,600. On Friday, the manager reduced the price by $640. By what percent did the manager discount the computer system? In order to solve and answer the example 2 question, we first must identify the part and base. Then we need to use the formula part divided by base equals rate. So first, the base for example 2 question is $1,600, the regular price, and the part is $640, the amount of the price that was reduced. So we're asked to find the rate of the discount. As shown in the diagram here, we'll cover R for the rate percent and need to divide the part by the base to solve the problem. Second, we would divide 640, which is the part, by 1,600, the base. We'll convert the decimal answer to a percent by moving the decimal point 2 places to the right and adding the percent sign. So shown here, it shows how we divided 640 by 1,600 and got the answer 0.4 as a decimal and converted it to a percent by moving the decimal point 2 places to the right and adding the percent sign, which gives us our answer to our example 2 question that the price reduction was a 40% discount. Always ask yourself whether your answer seems reasonable. For example, you know that 40% is a little less than half, and half of $1,600 is $800. Since $640 is a little less than $800, it is a reasonable answer. Now that we're more knowledgeable about how to solve for the part and base, let's move forward to practice 3.1 found on page 267. For our third practice questions, we're going to solve without a calculator. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Welcome back. Let's now review the following 3 questions together. Question 1 asks, what is 20% of $25? To solve question 1, we need to use the percent formula base times rate equals part. Our base for this first question is $25 and our rate is 20%. We need to solve for the part, so we need to change 20% to a decimal and multiply by 25. So 20% equals 0.2 and 25 times 0.2 equals 5. This gives us our answer of $5. Question 2 asks, Find 90% of 200. To solve question 2, we would do the same process as we did in question 1, with first identifying our base and rate. Our base for this question is 200, and our rate is 90%. We need to solve for the part, so we need to change 90% to a decimal and multiply by 200. So 90% equals 0.9, and 200 times 0.9 equals our answer of 180. Lastly, question 3 asks, what is 35% of 400? Just like we did with questions 1 and 2, we would repeat the same process with first identifying our base and rate. Our base for this question is 400 and our rate is 35%. We need to solve for the part, so we need to change 35% to a decimal and multiply by 400. So 35% equals 0.35, and 400 times 0.35 gives us our answer of 140. You may now pause the video and complete practice 3.1 questions 4 through 21. Click play when you're ready to continue. Solving for base. Some problems on the mathematical reasoning test may require you to solve for the base in a percent situation. Remember, the base represents the whole item or group. Read each situation carefully to figure out which element is missing. Then choose the correct method for solving the problem. For example 3, it says, in a math class, 75% of the students got at least a B grade on the final exam. If 18 students got at least a B, how many students are in class? In order to solve and answer example 3, we would first need to analyze the situation. The 18 students are part of the larger class. You know that the 18 students are 75% of the whole group, so 75% is the rate and the base is unknown. As shown in the diagram, we would cover B for the base, and we need to divide the part by the rate to solve the problem. Second, we'd convert the rate to a decimal. 75% equals 0.75 and divide. Once we convert the rate to a decimal and divide 0.75 by 18, it gives our answer of that there are 24 students in the class. Most of the time, we work with percents that are less than 100%. When a percent is less than 100%, the part is less than the base. However, it is possible to have a situation in which the part is greater than the base. When this occurs, the percent will be greater than 100%. Example 4 says, the workforce at Eastland Inc. is growing rapidly. The number of employees this year is 225% of the number last year. If there are 135 employees this year, how many employees did the company have last year? In order to solve an answer, the example for a question, we must figure out carefully which element is missing. That is, if it's either the base, rate, or the part. So first, the base, for example 4, is the number of employees the company had last year. The year's number is the percent of last year's number. Therefore, the rate is 225%, the part is 135, and the base is unknown. Second, would convert 225% to a decimal, drop the percent sign, and move the decimal point 2 places to the left, which gives us 2.25. Third, we then divide the part 135 by the rate 2.25, which would give us our answer to that last year there were only 60 employees. There's often more than one way to approach the solution to a problem. Both the percent formula presented in this lesson and the proportion method from lesson 1 can be used to solve example 4. As seen here, the formula method is written as 135 over 2.25, and the proportion method is written as 135 times 100 over 225. If you evaluate both methods using a calculator, both expressions equal 60, the correct solution. Note, don't begin calculations before you completely analyze the situation. Every percent problem has 3 elements. Make sure you know which one is missing before you multiply or divide. Now that we know more about solving the base, let's do practice 3.2 found on page 269. For the following practice questions, we're going to find the missing element in each set. You may not use a calculator. At this time, you may go ahead and pause the video to read and complete practice questions A 1 through 3. We will review them together afterwards. Click play when you're ready to continue. Great, you're back. Let's now review the following 3 questions together. Question 1 asks, $35 is 20% of what amount? To solve question 1, we would need to identify the part and rate. The part for this first question is $35 and our rate is 20%. We need to solve for the base, so we need to change 20% to a decimal. 20% equals 0.2. Then we need to divide the part 35 by the rate, 0.2. This gives us our answer of $175. Question 2 asks, 5% of what number is 14? To solve question 2, we do the same process that we did in question 1, with first identifying our part and rate. Our part for this question is 14 and our rate is 5%. We need to solve for the base, so we need to change 5% to a decimal. 5% equals 0.05. Then we need to divide the part 14 by the rate 0.05. This will give us our answer of 280. Question 3 asks, 3.2 is 50% of what number? Just like we did with questions 1 and 2, we would repeat the same process with first identifying our part and rate. Our part for this question is 3.2 and our rate is 50%. We need to solve for the base, so we need to change 50% to a decimal. So 50% equals 0.5. Then we need to divide the part 3.2 by the rate 0.5. This will give us our answer of 6.4. You may now pause the video and complete practice 3.2 questions 4 through 22. Click play when you're ready to continue. Let's now jump into lesson 4, percent calculator skills. By changing a percent to either a fraction or decimal, you can use a calculator to solve percent problems. Example 1 asks, what is 25% of 120? Try both decimals and fractions. So on your calculator, you would change 25% to the decimal 0.25. Multiply times 120 and press the Enter key. 30 will be on the right of the display on your calculator. To solve example 1, as a fraction, you would change 25% to the fraction 25 over 100 using the n over d key. Multiply times 120 and press the enter key. 30 is on the right of the display. Using either decimals or fractions, you can find that 30 is 25% of 120. When you use the percent second function, you don't have to convert the percent to a fraction or decimal. Practice the following function below to multiply to find the part when you are given the rate percent. Example 2 asks, what is 65% of $360? First, type the base 360 and press the multiplication sign. Second, type the rate 65. Press the second function key and engage the percent second function over the left parentheses key. Then press enter. The answer for example 2 would be the amount, $234, is 65% of $360. You can use the percent function to divide to find the base when given the rate. Example 3 says, Ned paid $150 for a stereo. The amount Ned paid was 20% of the original cost. What was the original cost of the stereo? Using your calculator, you'd first enter the base, which is 150, and press the division sign key. Second, you would enter 20 and press the second function key, and then the left parentheses key, and then you press enter. This will give us our answer for example 3, which is the original cost of the stereo is $750. Now that we've gained our new percent calculator skills, let's put it in use by doing practice 4 found on page 271. For the following practice questions, we're going to solve, and you may use a calculator to solve each question. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Yay, you made it back. Let's now review the following 3 questions together. Question 1 asks us to solve the following problem. Find 46% of $130. The answer for this question is $59.80. Question 2 asks us to solve the following problem. 14% of what amount is $13.44? Using your calculator, the answer for this question is $96. Question 3 asks us to solve the following problem. What is 12% of $126? The answer for this question is $15.12. You may now pause the video and complete practice 4 questions, 4 through 22. Click play when you're ready to continue. Now let's go ahead and cruise on to Lesson 5, Simple Interest. Interest is the fee paid for the use of someone else's money. If you put money in a savings account, you receive interest from the bank. If you borrow money, you pay interest. In each case, the amount that you invest or borrow is called the principal. Simple interest is a percent of the principal multiplied by the length of the loan. The formula for finding simple interest is given on the formula sheet of the mathematical reasoning test. See page 413. It reads as Interest equals principal times rate times time. You may find it easier to remember the formula using variables, letters that stand for numbers. I equals PRT, where I equals interest, P equals principal, R equals rate, and T equals time. Writing variables next to each other means that they are to be multiplied. Example 1 says, Asher borrows $2,500 from his uncle for 3 years at 6% simple interest. How much interest will he pay on the loan? To solve an answer, example 1, we'd first write the rate as a decimal. So 6% equals 0.06. Second, we'd substitute the known values in the formula and then multiply. So using the formula I equals PRT, we have $2,500 times 0.06 times 3, which equals 450. So our answer is Asher will pay $450 in interest. Some problems ask you to find the amount paid back. This adds an additional step to an interest problem. Example 1, Asher will owe $450 in interest at the end of 3 years. However, he will pay back the interest $450 plus the principal $2,500. When he has finished paying the loan, Asher will have paid his uncle $2,950. In a simple interest problem, the rate is an annual yearly rate. Therefore, the time must also be expressed in years. Example 2 says, Eva invests $3,000 for 9 months. She'll be paid 8% simple interest on her investment. How much interest will she earn? To solve an answer, example 2, we first must write the rate as a decimal. So 8% equals 0.08. Second, we need to express the time as a fraction of a year by writing the length of time in months over 12, the number of months in a year. So it would be 9 months equals 9 over 12 equals 3/4. Third, we would multiply. Using the formula I equals PRT, we'd have 3,000 times 0.08 times 3, which would give us our answer of Eva will earn $180 in interest. Now that we've covered simple interest, let's start on practice 5 found on page 273. For the following practice questions, we're going to solve these problems using the formula for simple interest. You may use your calculator. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Now that you're ready to move forward with practice 5, let's review the following questions. Question 1 says, Leo borrows $1,500 for 2 years at a 12% interest rate. Find the interest on the loan. To solve question 1, we need to use the formula for simple interest, I equals PRT. The principal for this first question is $1,500, the rate is 12%, and the time is 2. Next, we need to write the rate 12 as a decimal, 0.12. We'll then substitute the known values in the formula and multiply. $1,500 times 0.12 times 2. This will give us our answer of $360 of interest. Question 2 asks, how much interest would you pay on a loan of $800 for 6 months at 14% interest? To solve question 2, we need to first identify our principal, rate, and time. Our principal for the second question is $800, the rate is 14%, and the time is 6. Now that we've identified principal, rate, and time, We'll need to write the rate 14% as a decimal, 0.14. Next, we need to write the time as a fraction of a year by writing the length of time in months over 12, the number of months in a year. So it would be 6 months equals 6 over 12 equals a half year. Afterwards, we need to multiply $800 times 0.14 times a half, which gives us our answer of $56 of interest. Finally, question 3 says, Dominica invested $2,000 for 3 years at an interest rate of 7%. How much interest did she earn on her money? We will repeat the same process to solve question 3 as we did for question 1. The principal for this question is $2,000, the rate is 7%, and the time is 3. Next, we need to write the rate 7 as a decimal, 0.07. Afterwards, we will then multiply $2,000 times 0.07 times 3. This will give us our answer of $420 of interest. You may now pause the video and complete practice 5 questions 4 through 12. Click play when you're ready to continue. We have now reached our final lesson, lesson 6, percent of change. Percent is often used to show change. Example 1 says, Michelle recently started her own business. Last month she earned $1,000. This month she earned $2,000. How could she describe the increase in her earnings? All the following statements accurately describe the change. Michelle's earnings doubled from last month to this month. This month her earnings increased by 100%. This month's earnings are 200% of last month's earnings. Percent of change compares a new number which shows an increase or a decrease to the original number, the number before the change. For example 2, it says, before her raise, Lisa earned $10.50 per hour. Now she earns $11.34 per hour. What percent raise did her boss give her? To solve and answer the example 2 question, we first need to subtract to find the amount of change. So it would be $11.34 minus $10.50, which gives us 84 cents. Second, we need to divide the amount changed by $10.50, Lisa's wage before the change, and then convert the decimal to percent. So we have 84 cents over $10.50, which equals 0.08, which gives us our answer that Lisa's hourly wage increased by 8%. Think carefully about a situation to decide which number is the original amount. For example 3, it says, a jacket is on sale for $90. 3 days ago, the jacket was on sale for $120. By what percent was the price of the jacket reduced? To solve and answer example 3, we'd first subtract to find the amount of change, which would be $120 minus $90, which equals $30. Second, the price of the jacket was $120 before it was $90. So $120 is the original price. Divide the amount changed by $120. We have $30 over $120, which equals 0.25, which gives us our answer of the new price is 25% less than the price 3 days ago. Percent of increase may be greater than 100%. For example 4, it says, Calvin started his business with 10 employees. Now he has 60 employees. By what percent has his workforce increased? To solve and answer example 4, we first need to subtract to find the amount of change. So it would be 60 minus 10 equals 50. Second, we need to divide by the original number and then convert the number to percent. So we have 50 over 10 equals 5.0, which gives us our answer of Calvin's workforce has increased by 500%. At this time, let's do our last practice for the day on percent of change. Practice 6 can be found on page 275. For the following practice questions, we're going to solve as directed. If necessary, round your answer to the nearest percent. At this time, you may go ahead and pause the video to read and complete practice questions A, 1 through 3. We'll review them together afterwards. Click play when you're ready to continue. Welcome back once again. Now that you're ready to move forward with practice 6, let's review the following questions. Question 1 says, find the percent of increase from 2,000 to 3,000. To solve question 1, we first need to subtract 3,000 from 2,000 to find the amount of change. The amount of change is 1,000. Next, we'll need to divide the amount of change 1,000 by 2,000. After dividing, we'll get the answer of 0.5, which we would then need to convert to percent to give us our answer. Therefore, our answer for this question is 50%. Question 2 says, find the percent of decrease from $2 to $1.25. To solve question 2, we will repeat the same process as question 1. We first need to subtract $2 from $1.25 to find the amount of change. The amount of change is 75 cents. Next, we will need to divide the amount of change, 75 cents, by $2. After dividing, we'll get the answer of 0.375, which we would then need to convert to percent to give us our answer. Therefore, our answer for this question is 38% due to how we rounded to the nearest percent. Lastly, question 3 asks, what is the percent of increase from 30 to 90? We'll need to repeat the same process as we did for questions 1 and 2 to solve question 3. We first need to subtract 90 minus 30 to find the amount of change. The amount of change is 60. Next, we'll need to divide the amount of change, 60, by 30. After dividing, we'll get the answer of 2, which we would then need to convert to percent to give us our answer. Therefore, our answer for this question is 200%. We now pause the video and complete practice questions 4 through 15. Click play when you're ready to continue. Fantastic job, everyone! You completed Chapter 3. Now that Chapter 3 has been completed, don't stop here. You need to keep on going to the next chapter. When you're ready, go ahead and move on to the video for Chapter 4 called Data, Statistics, and Probability. See you in Chapter 4!